In this Chapter 3, we challenge you to modify the terms of the ELN to reflect changes brought about during your conversation with the customer and that might better reflect her preferences and her views regarding Microsoft's share price prospects over the next 3 years. Assume that in your conversation with the client, she expresses the view that the greatest upside she sees for Microsoft shares over the next 3 years should be somewhere around $90. You wish to help her monetize this opinion, which broadly means helping her earn money, provided she holds this view strongly enough as to be prepared to act on it and take certain risks. Most often, this is accomplished by identifying an option for the investor that she could sell consistent with this view, and then applying the premium she would earn to enhance the desirable features of the ELN that we had structured previously. This could be done, for example, via an increase in the guaranteed coupon of the ELN, or through the purchase of a larger number of call options to give her increased exposure to Microsoft upside, or even by lowering the strike price of the purchased call to enable her to participate in Microsoft upside starting from a price level lower than the current 60. We will examine 3 alternatives for tailoring the terms of the original ELN. Under the first alternative, which on the slide we are calling version 2, you are asked to reflect the investor's view that Microsoft will not rise much above $90 by having the investor sell a call option with a strike around 90 and by applying the premium received to double her exposure to future increases in Microsoft share price above $60. The solution we would like you to identify should leave the arranging bank with a profit margin of $0.75. You are also asked to write the term sheet for this version 2. You should click the pause button while you work on this problem. The option pricing grid on our earlier worksheet, Option Prices, indicates that selling a call with a strike of 88 would earn the investor a premium of $7.11, while a call at 92 would earn her a premium of $6.54. The second of these appears a little more appropriate since it is a little further out of the money and therefore reduces the risks to the investor, while nonetheless achieving the attractive benefit of bringing the net premium paid by the investor, i.e. the $13.15 paid minus the $6.54 earned, down to $6.61, which is roughly half the original premium of $13.15. Of course, other strikes in between these two possibilities could be chosen, but we will restrict ourselves to ones appearing already on this worksheet. Combining the purchased call at 60 with the sold call at 92, we would say that the investor has bought a call spread for a net premium of 661. But do please remember that she is purchasing one option while selling a second one. The call spread costing only 661 enables the investor to purchase two of these call spreads instead of just one call at 60. The sum of the bond and these two call spreads comes to an aggregate of 99.25, leaving for the arranger a profit margin of 75 cents, as indicated in the question. The term sheet for version 2 appears on this page. In the redemption amount formula, the max operator represents the payoff of the call options with strike 60 purchased by the investor. The 200% multiplier accounts for the fact that she has purchased two calls at 60. And the min operator ensures that the investor can never receive more than $164 at maturity, which we can decompose into the 100 from the bond and twice the $32, representing the difference between the strikes of the two options constituting the call spread. You might want at this point to plot a graph for your customer's benefit, which shows the performance of version 2 in comparison to that of the ELN. This graph should be self-explanatory. The greater steepness of the line for version 2, appearing here in blue, is consistent with the faster rate of participation in Microsoft Upside above 60, given that the investor owns two calls with a strike 60 instead of just one under the ELN, shown in red here. The same blue line, however, caps the investor's upside at $164. In contrast to the ELN, again, which is appearing here in red, which has no cap at all and can eventually outperform version 2 if the stock rises to very high levels, seen on the graph towards the extreme right when the stock reaches 125 or so. Changing the facts a little, the customer now tells you that she still wants principal protection and now wants a 2% annual coupon instead of just 1%. Also, that she wishes to participate in Microsoft Upside starting immediately, i.e. at $50 instead of starting at $60. Finally, she tells you that she refuses to accept a cap on her upside. You are asked to find a solution that leaves the arranger with a profit margin of 95 cents. This may seem at first impossible to achieve, since the bond and the purchased call will both become more expensive than they were previously. But you do have left the flexibility to reduce the participation factor as much as necessary to meet all other investor constraints and objectives. You should click the pause button until you have found the solution, and attempt please to write the term sheet as well. Worksheet version 3 solution appearing here reveals that the bond with the 2% coupon now costs $88.69. The worksheet also reveals that the call option with the strike of 50 costs $16.57, bringing the total to $105.27. Already this exceeds the investor's $100, and we have not yet accounted for the profit margin of the arranger. A minute's thought should confirm that you need to solve for the participation factor, P, set for now in cell H14 as 100%, that would solve the equation appearing in the rectangle, namely $88.69, price of the bond, plus dealer's profit, plus P times the price of the call option, must add up to 100 exactly. Algebra reveals that P is 62.5%, or 5/8. But of course this can also be confirmed via goal seek. Thus tools, goal seek, set cell G11, the value of the total investment, equal to value 100 by changing the participation factor in cell H14 and hitting OK, confirming the 62.5% participation rate. Therefore, under this version 3, the investor is able to earn a higher coupon than before and is able to participate in increases in Microsoft share price immediately above $50, but only benefits to the tune of 5 out of each $8, by which Microsoft rises from its current level of 50. Note, however, that under this version, the investor is not subject to any cap on her upside. The term sheet for version 3 appears on the slide and should be self-explanatory. In the formula for the redemption amount, note in particular the 62.5% participation factor and the lower strike of 50, as discussed previously. Changing the facts one final time, you are asked under version 4 to find a different solution that still provides the investor with her capital protection and a 2% guaranteed annual coupon, that permits the investor to participate to the tune of 100% in Microsoft upside starting at 50, and that leaves a profit of 75 cents for the arranger. However, the investor this time is willing to accept a cap on her upside. Click on the pause button until you have found the solution and prepared a term sheet as before. The worksheet labeled version 4 solution provides the answer and shows the investor buying a bond for 88.69, buying a call option struck at 50 for 16.57, and selling a call option with a strike we have labeled K and which we are currently pricing at 0. The worksheet once again leads to a total ELN value well in excess of 100, the amount the client has given us, even before taking into account the profit margin of the dealer. Once again, a moment's thought confirms, as shown in this rectangle, that we need to solve a linear equation, specifically 88.69 price of the bond plus the dealer's profit plus the 16.57 premium for the bought option minus the value of the option sold with a strike K must add up to exactly 100. As before, we can either use algebra to find a solution or go via Tools, Goal Seek, where we set cell G13 for the total investment equal to value 100 by changing cell G9 and hitting OK, revealing that the call that we need to sell must have a value of $6.02. A quick glance at our earlier worksheet option prices reveals that the level of strike K is exactly $96. The term sheet for this version 4 appears here and should again raise no surprises. In the formula for the redemption amount, the max operator represents the payoff of the call option struck at 50, while the min operator ensures that the investor can never receive more than $146 at maturity. This again we can decompose into $100 from the bond and $46 being the difference between the strikes of the two options constituting the call spread, namely 96 and 50. It is useful at this final stage in our discussion to plot a graph that could help your customer best understand the pros and cons of each version we have discussed with her. For the most part, the graph should make immediate sense to you. The two horizontals at the top right, over here, represent those two versions, specifically version 2 and version 4. Here's version 2 and here's version 4, under which the investor has sold a call or two calls and thus has accepted a cap on her upside. These appear, as you see, in brown and in red. The varying steepness of each diagonal reflects correctly the different participation rates under each version of the instrument. One important subtlety to note about this graph: is that since we have decided to plot only the final payoff at maturity rather than the instrument's IRR, the graph does not take into account differences in the coupon rates paid under each of the different versions. In a sense, the graph discriminates unfairly against versions 3 and 4, which carry the higher coupon of 2%. We could, of course, have avoided this problem by plotting on the y-axis the IRR instead of the final payoff. But we wanted here to focus you more specifically on what causes the final payoff to differ under each version. This is a good time to conclude this module and to ask you to test yourself by answering the 4 quiz questions coming up next. Chapter 3, therefore, ends here.